Good afternoon, everybody. Welcome to our Russian Summer School for Institutional Analysis. We're very happy to have you here. And today is a very special day because it's our 15th summer school, which was supposed to be in a very nice resort outside Moscow with lectures under nice trees, under sunshine, having some beer in the evening and having some morning exercise in the mornings. So, but life introduced some circumstances into our life, but that's life. And we decided not to interrupt our summer school sessions and to have it in very unusual form. Why we do that? Because our summer school is for community of those young researchers who are interested in institutional economics and doing research in institutional economics. And our principal aim to contribute in building community and society of people around the world who want to do world-class research on institutions. So that's why you are here. And that's why we have new participants for the summer school this year. And we're very happy that we can support you with our lectures of our faculty dream team, but also for discussion papers for our participants as well. So I'm pretty happy to see here first our current school participants, but also those people who are our Russian Summer School alumni. So glad you are here. Hope you're going to enjoy this event as well. But also we decided to make this event open for general public. And it's really great that many people who are interested in this research are here with us today. We have a greater faculty team this year. We can't meet in person, but I believe we still can enjoy intellectual discussions and intellectual talk with them and listening to great presentations. And today we have our first speaker. Our first speaker is Gerhard from New Economic School. He's assistant professor in New Economic School, which is really partner university partner school for our high school of economics. And Gerhard got his education from Oxford University, and his main focus of research is natural resource economics. And his lecture today gonna be on natural resource economics. Exactly, exactly. So I suggest we do that in the following way. First, please put your name in chat so everybody can see who you are, and please put your country together with your name. I'm happy that we have many countries here, so let's see how rich is our group. And also, if you have any questions and comments, please put them in chat. So when Gerhard finishes with presentation, he will be able to respond to your questions. Please don't be shy. Ask whatever you want. We are here to have wonderful lecture, but also wonderful discussion and really talk to you and learn about your questions, ideas, contributions. And still, any work, we believe, is a work in progress, which means that when you ask questions, you get something from answers, but you also contribute in building better research for the future. Raising questions might help to give a birth to excellent partnerships in the future, excellent papers, excellent research to follow. So please don't be shy and enjoy Gerhard's talk. Gerhard, thank you so much for accepting our invitation to be at our summer school.
Thank you for inviting me.
You're first in row to start, and I'm pretty sure that's going to be a brilliant start. Right. The screen is yours.
The screen is mine. Okay, am I allowed to share? Yes, I do have the power to share.
Yes.
Okay. So could somebody please confirm that you actually see the slides?
We do.
Okay. So hello, everybody. I'm very happy to be here with you. Well, not physically, electronically. And the goal, which I've set for the next 60 minutes, is basically to communicate to you 3 ideas. First, I will give you a very rough overview of the big ideas in natural resource economics and politics, starting roughly 250 years ago, going until today, to set the scene, just to get a feeling for what people are worried about in this literature. And then how can you position the paper I'm going to present afterwards in this literature? The second point will be, by now, a very standard idea of the, which is very well developed theoretical idea in natural resource economics, and also very famous in policy circles, but frequently misunderstood and people are confused about it. So I decided this makes sense to discuss it here. And this will be the idea of the Dutch disease. And the third thing which I'm going to do by presenting this paper is introducing you to what I would say is still a literature which is growing fast and there's lots of potential: cleaner identification in macroeconomics. So those of you who did economics, I actually don't know whether most of the students, I guess most of the students are economists. Is that correct? Is that the correct assumption?
Yep.
Yeah, okay. So most of you have, at least, even if you don't work empirically, you have at least heard of Engels and Pischke. And Engels and Pischke kind of push the idea of causality in the use of natural experiments in the absence of the possibility to do an RCT, and randomized controlled trial, in microeconometrics. But I think there's still lots of room to do this in macroeconomics more carefully. And I will give you one possibility on how to do those things in the context of testing for predictions which can be derived from the simple Dutch disease model. So these are the 3 ideas: rough overview, paper. In the paper, I introduced to you the idea of the Dutch disease, and then how you can do identification in macroeconomics. And I will refer to a specific literature which is growing and which is also pushing for the idea that there is lots of room to improve this. Since we're not in person interacting, I don't see you, so I don't know whether you have questions or whether you're confused, whether I'm going too fast, whether I'm going too slow. This is a disadvantage. The advantage is that you can join from all over the world without any transportation cost, but the disadvantage is I don't see you. So let's do it the following way. I will, in the next 50 minutes, try to go through these 3 points. If you have a question, if something is unclear, please write it down, put it in the chat, and I will try my best as soon as I'm done to go through this and answer this chronologically. Okay, let's get going. So 25% I will use for a quick introduction of the subject, and then I will present a paper of mine where I use those 2 concepts which I described in the subsequent 75% of the time. If you're interested in natural resource economics, then the 2 books which I would highly recommend, and I'm a big fan of, is Jürgen and Diamond, 2005. Diamond is Gerhard Diamond. He basically goes through history and tries to understand how some civilizations survived and some died, and natural resources and climate change seems to play a big role. So very much recommend this book. Jürgen is basically the first guy who wrote down the history of fossil fuels, basically starting in roughly mid-19th century and discussing basically what happened in the last 150 years related to oil and gas, and very heavily linked to institutional economics. He is an international relation historian person, but the ideas there discussed are often very strongly related to institutional economics. Now, the classical papers and how natural resource economics I think, would have been taught up to roughly 10 years ago would be those. So you would teach Malthus, Jevons, Pigou, hotelling. Pigou, most of you have heard of because of externalities. Hotelling, most of you have heard because of the beach example, not this particular paper, which thinks about optimal extraction. What I will do is I will quickly talk about this, but then I will zoom in on the literature which is related to natural resources and which has been developing in the last 20 years. And I will start at the beginning, I will start with Malthus. Quick clarification before we go on. We typically distinguish between renewable and non-renewable resources. The difference between those two is, does the resource renew itself at a sufficient rate for sustainable use? If it doesn't, if it takes millions of years to produce it, then we call it non-renewable. This is fossil fuel minerals. If it's does, in principle, can renew itself at a sufficient rate for sustainable use, we call it renewable. This is timber fisheries. What I will do is I will focus on those. So I will focus on the non-renewables. When we talk about non-renewables, since Malthus, so really since very much the very beginning, but all those guys subsequently essentially worried about the same two things. And we're still worried about this. We're somehow consciously or subconsciously worried that at some point we will run out of the non-renewable resource. I guess people intuitively think, okay, there is a limited amount of the resource in the ground. If we use it up too fast, we will lose it, and then we will all die. So the ideas of peak coal and peak oil speak to this anxiety. The other one, much more recent in an extreme form, but also actually existent since Jevons, who already was worried about, and Pigou, is the other worry that while using the non-renewable resources, we actually pollute the local environment and potentially contribute to climate change. Again, those ideas have been around for 200 years, and these authors were already worried about this. I will quickly talk about running out of the resource, and the first person to think and worry about this was indeed Malthus. And most of you have heard of the Malthusian catastrophe. The idea is that on the x-axis you have time, on the y-axis you have the quantity, and if the population is growing much faster than an essential resource for any type of production, you're worried that at some point the fact that resources are constrained will need to pull down population back in terms of the quantity. This can happen because of starvation. This can happen because of conflict. There are many reasons for this. And this is something Malthus was already worried about 150 years ago. Did this happen? Well, this is why I started with the book of Diamond. Diamond in 2005 has excellent examples on this. I will give you one example which is not in Diamond and which most of you have never heard of. So there is a tiny island which is called Nauru, which is in the northeast of Australia. And let me tell you briefly what happened to Nauru in the last 70 years. In 1975, this island had the highest GDP per capita on Earth, higher than Qatar and Saudi Arabia. Why? Well, because of birds' feces, they had large phosphate deposits on top of the island. Unfortunately, they completely mismanaged this resource. They extracted it far too fast and made really bad investment choices. As a result of this, GDP per capita is nowadays approximately $10,000 US in purchasing power parity, and they're completely dependent on Australian aid. So here you have a clear example. Yes, you can physically run out of the main natural resources, which is heavily contributing to your economy, and by doing so, screw up completely your economy. Is it inevitable? No. There are also examples how you can fix those things. I will not go into this. My job at this point is to excite you that there are problems, and natural resource economics deals with these type of questions. The other one is pollution and climate change. I lived in my life in 3 different countries, in Germany and the UK, and I moved to Russia recently 2 years ago. I have the impression that debating about climate change relative to Germany and the UK is at a different level. So up to now, you even discuss with people whether climate change is happening, which is surprising to me. So this is not a debatable thing, it's a fact. Climate is changing. Whether it is caused by human activities or not, this may be debatable. I think I'm already convinced to one of the sides. I'm not going to talk about it much, but it's really not debatable that temperature is increasing. And since I've been in Moscow this winter, I experienced, to my disappointment, a horrible winter. Why? There was essentially no snow. So what did I decide to do? I'm an empirical economist. What do? I get data and then I just look whether there was a structural break in the temperature of Moscow in the last 70 years. So this is simply me getting data and looking at it. On the x-axis, you have time. On the y-axis, you have average temperature in December. This December, the average temperature was close to 0. There was essentially no snow. If you just do a simple endogenous structural break determination test, you find that there is a structural break roughly in 1960. Since then, temperature has been increasing. And if you follow this specific trend, by 2050, average temperature in December in Moscow will be 0. Now, has there been in history, similar question to the previous one, a situation where climate change actually led to the distinction of civilization? The answer to this, again, you can find in Diamond, and the answer is yes. The classical example which you would use would be the example of the Norse. These are the guys who basically moved from Scandinavia to discover the America and the west side of Greenland. And in a nutshell, again, without going into detail, I recommend Diamond on this specific story. The Scandinavians began the civilization of North America roughly 1,000 years ago. 500 years later, they were extinct. And historians collected by now enough data which suggests that climate change, in combination with the misuse of local resources, deforestation in this case, contributed to the extinction of the Norse. Summing up, natural resource economics traditionally was concerned with 2 things. First, climate change and pollution. Second, running out of a resource. We know from the past this indeed has happened, so it's an issue and we need to deal with this. Now, in the last 20 years, the literature moved in a slightly different direction. The seminal paper here would be Sachs and Warner, which I'm not citing for a variety of reasons. If you want an introduction to this literature, I would recommend Venables, which is Journal of Economic Perspective, and a summary article, or Michael Ross, who has a book on this, and it's called The Oil Curse. And basically, the contribution of this literature is now to say, look, we have analyzed those 2 problems. The issue is, in most cases, we know what to do, but unfortunately, the availability of resources seems to screw up the decision-making among policymakers. So there is this idea of a political resource curse. And this means that we cannot, unfortunately, solve those 2 problems which I raised because the policymakers seems to be somehow negatively affected by the availability of resources. So this is done. So I'm done with the introduction. Now I will move on to the paper I'm going to present. And I will in particular talk about Dutch disease. Now let me link this to the literature.
Maybe you can try to answer a question in.
Oh, absolutely! I'm happy. But then I need to stop.
Should I read or?
Wait, there are 20. Well, I can.
No. The question only the last one.
Okay. Yeah, sure. If there's just one question, let's go with the question, because I'm actually preferring to question. Yes. Okay. Yeah. So let's do it the following way. If there are not too many questions, I'm happy to interrupt because I think this will be more natural. If there are too many questions, then maybe we will postpone to the end.
I will manage this. If I will see any questions,
Cool.
I will
Thank you.
stop and say you.
Thanks. So let me quickly tell all of you the question. So what happened? So you mentioned that there is 0.8 degrees Celsius change in 100 years. Is this globally? Yes, this number is globally. Now the question is there cross-country heterogeneity? Yes, there is lots of cross-country heterogeneity. In fact, there are countries which are net benefiters of global change. So countries like Russia and Canada, for instance, net, not exclusively, so there are also downsides. One of my students actually wrote a paper on that this year, which was very good, I thought. But net, Russia and Canada seem to benefit, are anticipated to benefit from climate change. This is 0.8 is an average. And the reason I'm mentioning this also is because the structural break perfectly coincides with the calculations for Moscow. So this is not a Moscow specific thing. The structural break occurs globally roughly 70 years ago, 40, 60 years ago. So I will talk to you, and this is my field of expertise, so I'm familiar with this literature, but I guess most of my work is in this literature, so it's really the link between economics and politics. And the paper I'm going to talk about today is joint work with two colleagues of mine. And it's essentially a paper which tests empirically the prediction of the Dutch disease model. Now, before we start with the paper, let me clarify one thing, because it's a constant confusion among many people I'm meeting. People tend to mix up the term Dutch disease and resource curse. These are different terms. And Dutch disease essentially is one potential channel for the resource curse, whereas the resource curse is the overall idea that countries economically do worse if they have resources. And the seminal paper on that is Sachs and Warren, and they show that countries with resources seem to grow slower relative to countries without natural resources. 2 points on that, and then we go to the paper. By now, the literature is such that there is really little evidence on this claim. So despite the fact that the term is really famous and most people have heard it at some point, there is no evidence for this. So on average, countries with resources do not grow slower than countries without resources. No evidence for this. And if countries do suffer from resources, there are some, again, on average, that doesn't seem to be the case, but there are some who benefit a lot, like Norway, that would be the good example. But there are also some which do not benefit a lot. This is predominantly due to political economy issues. So things like corruption, bad people coming into power and doing bad things, war, revolution, conflicts. So yeah, this is just to make sure that we're not mixing up. So we're not talking about the resource curse in general. We're going to talk just about the Dutch disease, which is a potential channel for the resource curse. So what is the motivation to look at this at all? Well, if you look at countries which are extremely resource rich, like Luanda, which is the capital of Angola, is frequently ranked as one of the most expensive cities in Africa. If you, in 2014, when the oil price was still high, would compare the price of a Big Mac in Oslo, the capital of resource-rich Norway, and Stockholm, the capital of resource-poor Sweden, you would see that the Big Mac is roughly 30% more expensive in Oslo relative to Stockholm. And you can come up with many other examples. So my favorite one is actually, in many cases, if you land in an airport of a resource-rich economy in times of a resource boom, and you want to take a cab from the airport to the capital, you will pay huge amounts of money. So it seems to be that resources during booms somehow seem to be related to prices. Well, in a seminal paper, Gordon and Neary in 1982 actually develop a model which links resource boom to labor reallocation across sectors and the prices of non-tradable goods. A few years later, The Economist, so the magazine, would advertise this paper using the idea of the Dutch disease. And the reason it's called Dutch disease is because the case study where this relationship was observed first was in the Netherlands, hence Dutch, and it's called a disease for reasons we will discuss in the next couple of slides. And since I already mentioned, since it's frequently misquoted and misunderstood, let me spend some time discussing this. And what I basically did is I will introduce to you a very simplified, the simplest possible version of the model to get the ideas clear in your head, and then we can go ahead and test those ideas. So think about a very simple economy with just 3 sectors, which have very simple production functions and just depend on labor, and all are concave. So you have the oil sector, which has a productivity shifter and uses labor to produce an output. You have the manufacturing sector, which we will refer to as tradable, which has a productivity shifter and uses labor to produce it. And we have the non-tradable sector, which has again a productivity shifter and uses labor to produce it. Now the prices of the oil and the manufacturing goods will be set to 1 because they're fixed internationally. It's a perfectly tradable good. It's a simplifying assumption, makes ideas clear, allows us to structure thoughts. Well, we allow the price of the goods which are produced locally to change, and we will call that P and T. Now, with those 3 sectors, we will allow labor to reallocate without any friction across sectors to equalize the marginal revenue product. We will assume that labor is fixed. We're talking about the country level, and we abstract from migration. It's really easy to allow for migration, and we can discuss the consequences of migration later. For the time being, we will just assume no migration. And then we assume, to close the model, that total income, where we'll just talk about wages times labor, will be spent partly on non-tradable goods. So theta is a share, let's say 50%. So what does it mean? We're having a simple economy with 3 sectors. Labor is allowed to reallocate to equalize wages. Employment is fixed on the country level, and all the income we abstract from profits. Again, allowing for this will not matter. A part of the income is spent locally on non-tradable goods. Just for those who are not familiar with those terms because you're working in different dimensions, think of a tradable good as a TV or a radio, and think of a non-tradable good as a barber or hairdresser or waiter in the restaurant, something like that. So what's going to happen if you shock this economy? Now, let's say we allow the productivity shifter of energy to change. How do you think about this? You think about it as a huge discovery. Let's say Mozambique, for instance, 10 years ago was a resource poor economy. Then they had huge 2 gas discoveries and they became resource rich. Netherlands 50 years ago was resource poor and then they had huge gas discoveries and they became resource rich. The UK and Norway up to the 70s were resource poor and then a lot of oil was discovered in the North Sea, they became resource rich. So what happens to such a simple economy which we just set up if you have a discovery? Well, Gordon and Neary basically say you will have 2 types of effects. And one they call a resource movement effect, and one they call a spending effect. What is a resource movement effect? It's quite intuitive. If you have suddenly a lot of oil, a lot of people will start studying oil engineering and try to become, like, I think in Russia, for instance, many people want a good job with Gazprom and Rosneft. Before oil existed, you wouldn't have the possibility to go there. So this means that workers go from the other 2 sectors, from services, non-tradable and tradable manufacturing, to the oil sector. This is the resource movement effect. So workers reallocate to the booming sector. But on top of that, you have the spending effect. And the spending effect is basically the idea that suddenly people have more money. And since we assumed that at least part of the money is spent locally, what is going to happen? There is suddenly more demand for tradables and non-tradables. Because they have a high income, there is more demand for tradables and non-tradables, and we assumed part of it is spent locally on restaurants, on hairdressers, on gyms, on massages, whatever is a non-tradable good. And this spending effect leads to the fact that now the service sector is booming and taking workers out of the tradable sector into the service sector. These are the 2 movements. So the first one, suddenly people want to work in the oil company. And the second one, because people have the money, more money, they have spent it on waiters or other local services. And this pulls workers into the service sector. Let's look at it a bit more graphically. So on the x-axis, you have workers of an economy. On the y-axis, you have the wage. Here, you have the marginal revenue product schedule of the non-tradable sectors. The more people work in the service sector, the lower the wage. Here, you have the marginal revenue product of schedule of the tradable sector. Again, the more people work here, the lower the wage. And this one is the combination of both tradable sectors, the tradable manufacturing and the tradable energy. Now, if you suddenly have a boom in energy, what this simply means is that this marginal revenue product schedule shifts up and workers reallocate from the service and the lagging tradable sector to the service sector until the wage equalizes. This is the resource movement effect. And once they have more money, they spend it partly locally. This boosts the service sector. So the marginal revenue product schedule of the service sector shifts up and leads again to reallocation of workers from the tradable to the service sector until the wage equalizes. Most importantly, since the lagging tradable sector, so the manufacturing sector, is neither booming nor can adjust local prices, it means that both the resource movement effect and the spending effect are crowding out labor from the manufacturing sector. And this very idea that a tradable sector, which is not booming, cannot adjust to local market conditions, and cannot pay higher wages because the price of the product they're producing is fixed internationally. This is the very idea of the Dutch disease. So the resource movement effect and the spending effect jointly crowd out labor from the lagging tradable sector, which we think of as manufacturing. Now, at the same time, since wages are increasing, and since this is translated in the prices of non-tradables, this means that prices of non-tradable goods are growing. Now the restaurants, in order to attract more waiters, and the hair salons to attract more barbers, need to pay them higher wages, also charge higher prices. And this automatically will be reflected in an increase in the aggregate price level. And since the real exchange rate is essentially comparing the price level of one country relative to another, to an appreciation of the real exchange rate. How do we think about this in the context of the resource movement effect and the spending effect? I think the easiest way to think about it is on the x-axis, you have the quantity produced of non-tradable goods. On the y-axis, you have the price of non-tradables. The resource movement effect crowds out workers, takes them from services into the energy sector. And the spending effect increases demand for non-tradable goods and pushes up prices. Both jointly push up the price of non-tradable and crowd out workers in the lagging manufacturing sector. So, to sum up, the Dutch disease idea refers to the crowding out of the tradable goods sector, which is lagging and not booming, which cannot adjust prices locally due to import competition and the appreciation of the real exchange rate. The origin of the term is the collapse of Dutch manufacturing after natural gas has been discovered in the 1960s, hence Dutch disease. But it's only a disease if we believe that this lagging tradable sector, is actually crucial for long-term performance. Economists tend to believe that tradable, well-developed manufacturing sector is very important for long-term economic growth. And if this is true, then it is a disease. Otherwise, it's simply an efficient allocation of labor and other factors of production. So, this is the basic idea of the Dutch disease. We have a boom in one of the sectors. Workers and other factors of production are reallocating to the booming sector. This generates more money in the economy. People are spending part of it locally. This generates a boom in the service sector. Both booms in the energy sector and in the service sector crowd out the manufacturing sector. And since the reallocation requires an increase in the wage, this is translated to higher prices of non-tradables, which leads to an appreciation of the real exchange rate. So by now, I 3 times repeated the same story. I do that, of course, on purpose, just to fix ideas. How do we test this? Well, as I emphasized, my understanding is that identification is already at the core of lots of the microeconometrics literature, but macro is a bit lagging. And this is mainly because it's difficult. It's difficult to come up with a decent identification strategy. I would, for those of you who are interested, recommend this book in particular for more examples on different ways to do this. So this is a book focusing on natural experiments in macroeconomics. So what am I going to tell you now? Well, I will start with thinking about the ideal experiment. So how could I test this appreciation reallocation channels? Well, an ideal experiment would be that I would get 50 countries. 25 of them I would randomly allocate to have a discovery. And then I would have this discovery realized, and then I would wait for 5 to 10 years and then compare the exchange rate of and the share of manufacturing workers in the treated sample to the control. Obviously, no government is able or would me allow to do something like that. So we need to think about how to come as close as possible to this ideal experiment. And one way to do this is to mimic this by making a couple of arguments. Before I go into the identification strategy, let me construct data with you so I understand which data we're talking about. So we will use two different types of sources on data. First, to construct local price indices, we will use data from the UN, which provides data on value added, nominal, and real. And they do this on the sectoral level. So you can have the manufacturing sector and you can have the service sector. Now, in the baseline, we will treat agriculture, construction, and services as services or non-tradable. This can be changed. It's not important for the results. And we will treat manufacturing as tradable. So, with having those sector-specific price indices, we can construct bilateral real exchange rates for the whole world. This gives us roughly 15,000 observations per year. And we would have the bilateral real exchange rate always expressed in dollars, the price level of country I relative to price level of country J for the pair RJ. Now we follow Betts and Kehoe to do a very simple trick and decompose the price levels into tradables and non-tradables by simply multiplying and dividing by the price of tradable goods. And remember, the price of tradables is coming from value, nominal and real value added for manufacturing. So we essentially have three terms. We have the relative price overall of country I relative to country J, the relative price in the tradable sector, and the relative price in the non-tradable sector. Remember, the tradable sector we assume is fixed internationally, such that we shouldn't see large jumps in the prices ratio of tradables in one country relative to another country, because they should be fixed internationally. On the other hand, we do allow for deviations of prices of non-tradables in country I relative to country J. So this is the left-hand side variable we're interested in, price differences. And now let's combine this with the data set on discoveries, which allow us to mimic resource abundance. So we construct, and here we follow a paper by Areski and co-authors, the net present value of discoveries in country I at time t relative to pre-discovery GDP. What is this? Essentially, you take the production in period t going onwards for a specific discovery. You multiply it times the current price, suboptimal, but often the prices in natural resources are, in particular in case of oil, are modeled as a random walk. So the best predictor of future price is the current price. And then we discount it with a country specific interest rate. So this gives you roughly the net present value of a discovery. So at the time when you discover something, how much value do you have in your hands? And then you divide it by GDP. So if you have something like 0.1 here, this tells you that you just made a discovery which has 10% of your GDP. Why? Why do we take those large discoveries? In fact, they're called giant discoveries. Well, giant discoveries are defined as all those discoveries which have 500 million barrels of ultimately recoverable oil or gas equivalent. And as I will argue, the timing, this will be crucial, the timing in which such a discovery is made is plausibly exogenous. Not the location, but the timing. Moreover, if you have a giant discovery, presumably you will have a reasonably large effect size. This means that power issues are less of a concern. So you're less likely to make a type 2 error, so non-rejection of a null hypothesis, which you would do in case of small discoveries. So you focus on the big discoveries. How do they look like, to give you a feeling? So on the x-axis you have time. On the y-axis you have the value of the discovery, net present value of the discovery relative to GDP. So Norway, for instance, had a discovery in 1984 which had the size, the net present value of Norway's GDP, so roughly 100. So big potatoes. Mozambique, which is a case study which I'm using in another project of mine, got particularly lucky in the last 10 years because 3 times in a row they made discovery which roughly add up to 50 times the country's GDP. So within a day, the country goes from having a GDP of X to presumably in the future getting additionally 50 times X. So lots of money, lots of changes. Since we'll work with ratios, it will become apparent why we're doing this. We will need to do a simple monotonic transformation. So we will just add a 1 to the 0.1. And this changes slightly the interpretation, meaning that if you now have a discovery of 10%, this number will be 1.1. So GDP is by 10% larger than it would be without the discovery. And we need to do this because we're constructing bilateral pairs. And we cannot have 0 in the denominator. So if you wouldn't add the 1, delta would be still simply equal to D, and then we would need to divide by 0 if a country doesn't have a discovery. But once we do this transformation, we can construct this capital D simple variable, which is essentially our treatment variable. If you happen to have a discovery in country I, but no discovery in country J, this means that in country J, D is 0. So delta is 1, so this is 1. If in country 1, you have a discovery which is 10% of a country's GDP, this means delta I is 1.1, so this is 1.1. 1.1 divided by 1 is 1.1, so we're talking about 0.1. On the other hand, if you do it just the other way around and you don't have a discovery in country I, then delta is 1. Delta J has a discovery, so it's 1.1 in case net present value is 10%. So the number here ends up being roughly 0.9, and the log of this is minus 0.1. So if you have the discovery in one country, you have, which is 10% of GDP, this value will be 0.1 in case this country which makes the discoveries in the denominator, and it will be minus 0.1 if it's a denominator. If this was too much information, do not worry, this is not crucial. The more important part, because these are technicalities, so our results do not depend on this. But what our results depend on are the idea that the timing of the discovery is plausibly exogenous. Because the identification strategy essentially relies on comparing changes in the real exchange rate between two countries before and after the discovery. And the idea being that the real exchange rate will appreciate after the discovery relative to before. To give an idea why discoveries and the timing of discoveries is plausibly exogenous, let me quickly give you the 101 introduction in geology, geological basins. So geological basins are basins where stuff can accumulate. In particular, sediments accumulate there, which are brought there by wind and water. Sometimes those sediments cover organic material which contains carbon. So we are dying and we're covered by sediments, or trees are dying and they're covered by sediments. So it doesn't allow the organic material to oxidize back to CO2. And if the organic material stays under the pressure of sediments for many years, this turns into fossil fuels. This is it. How does it look like? Well, you can construct nice maps like this, which basically indicate the most promising basins. So the gray areas are those areas of the world where you're more likely to get one of those giant discoveries. And of course, all companies are aware of that. They're not stupid. They've been studying this for many years. So they drill there. So the black dots are the exploration wells in non-OECD countries. And what you see, of course, exploration takes place predominantly in the gray areas. And once in a while, this exploration well will turn into a giant discovery, which is the red dot. So we're not arguing, of course, that the location is exogenous. Companies know where they want to drill, and the location is exogenous. They know we're not arguing that the location is exogenous, because that would be ridiculous. Companies know where to drill and they drill there. But we're arguing that the exact timing when the discovery is made is by the very process of exploration drilling. It's called exploration, unknown ex ante. To give you a very clear example of this, which I like as an example. So from the Financial Times, 2010, in 2010, Lundin Petroleum made one of the largest discoveries of the year and one of the biggest in Norway ever. It was found within 3 meters of where another company drilled roughly 40 years before this. This should give you an idea about the randomness of the process. So just moving 3 meters further and you get lucky. The location is the same, but 40 years apart with trying and realizing a discovery. So with this identification and these two data sources in mind, this will be the estimated specification. On the left-hand side, we will have 3 different variables which indicate the change of prices in country I relative to J between two periods. And there will be 3 different terms for this: overall real exchange rate in the tradable, real exchange rate in the non-tradable sector. Remember, we would expect the tradable sector not to be affected and the non-tradable sector to appreciate and drive the real exchange rate. Then we have a country pair fixed effect, which in the specification where you have growth rates on the left-hand side accounts for a linear country pair specific trend. And we have a time fixed effect. And this is our treatment variable with 5 leads and 10 lags. Now, in order to identify the overall impact of a discovery within 10 years on the relative prices, what we want to do, we want to add up the betas, because the betas tell us how in period K, let's say 5 years after the discovery, grows relative to the country-specific counterfactual, the growth rates before the discovery and from 10 years onwards. We add those 10 up, and we can plot omega. And this is what you get. So on the x-axis, you have time. The vertical axis is the year of the discovery. The years before the discovery are the leads. Ideally, you do not see anything significantly different from 0 there. And here we start seeing an appreciation of the real exchange rate. If we decompose into tradables, we see tradables are not affected, but the prices of non-tradables are increasing. Consistent with the idea of the appreciation of the real exchange rate following a boom in the energy sector, according to the Dutch disease model. I don't have time for this, but we also construct a simple theoretical model, and we can just compare the overall magnitudes. And the model gives us that within 10 years, a discovery which has the value of 10% of GDP should increase the real exchange rate by 1 to 4%, and it should be true exclusively by non-tradables. These are the results which are given to us by the empirical specification which I've just shown you. Now we can push this a bit further and get additionally data for OECD countries where we end up getting data going back sufficiently far in time on the reallocation of labor. And we construct a similar, albeit slightly different estimation for those countries and do two things. First, we test this in this subsample, the results are identical for a baseline, and we find they are indeed. In terms of magnitude, qualitative and quantitative, they are identical. But then we zoom in and ask, so what happens to labor across sectors? And what we find is that the share in manufacturing after the discovery is actually decreasing. And moreover, we find that labor becomes more productive in manufacturing and less productive in services, which is perfectly consistent with a concave production function. Plotting again the results from this model relative to the theoretical model gives us again very similar magnitudes. Let me sum up. I can go in detail, but I'm not sure whether you're with me. As I said, there are advantages and disadvantages to being in this form of presentation. Let me wrap this up and let you ask questions. If you don't have questions, I can zoom in on one more issue, which I think is important. So overall, I've introduced to you the basic ideas and questions of natural resource economics and politics. I zoomed in on one specific question, which is related to the resource curse idea, and this is the Dutch disease. I presented to you the basic concept of the Dutch disease, and then I took the predictions to the data and explained to you natural experiment using giant discoveries to mimic an ideal experiment looking at the channels predicted by the Dutch disease model, appreciation of the real exchange rate and reallocation of labor. And we do find that different methods suggest that 10% of GDP that a discovery which has roughly the value of 10% of GDP increases the real exchange rate by roughly 1.6%, exclusively by the appreciation of the non-tradable good prices, leads to the collapse of the manufacturing sector by 0.5 percentage points, and affects labor productivity in the expected direction in the service and the tradable goods sector within years, 10 years following a discovery. So I told you everything I wanted to tell you, and I communicated the main 3 ideas which I wanted to share with you. Do you have any questions?
Yes.
Now you can turn on your mics and ask question by voice. I see one more question in the chat.
Shall I go myself to the chat? Let me go to the chat. Okay.
Okay, I have one. Sorry. May I? It's Olga Vasilieva.
Yeah, Olga, you are welcome.
Hi.
Okay.
Hi, Gerhard. I
Yes.
have one very stupid, very silly question.
No, you know that there are no such questions.
Okay, good. Look, are your results robust if you look at, say, not ratio, deposit to value of deposit to GDP? Just, I mean, if you look not just ratio, but just deposit value. You understand? There is a critique that if you look at the shares or ratios, it might produce you downward bias, and you can you can have long discussion why it might be, why it's better to look at share of say value of
I'm not
deposit.
sure. Let me try to just ask to make sure that I understand. Are you asking? Are you suggesting that we should use a different measure on the right-hand side instead of using a giant discovery? You're suggesting to using all available deposits.
No. What if you look just at net, discovery of deposits, not the share in GDP?
Oh,
the ratio to GDP.
Okay. So you're suggesting not looking at the not having GDP on the right hand side, because obviously GDP is related to all sorts of things.
Yes, exactly.
And hence, yes.
Yeah.
Okay. Yes. So what we do is an obvious. No. This is not at all a silly question. Let me actually elaborate on this a bit. This is literally the only project in which a right-hand side variable in my regression has GDP, because of the concern you're having. The thing is that this is how the literature started doing this, and this is why we did it this way. But all our results can be easily reproduced by simply having a dummy for the timing, because the timing is the crucial thing and zero otherwise. And I think that completely should address your concern, right?
Okay, yeah. So baseline version is just done.
I don't hear you.
Sorry. Hello.
Yes.
Can
yes.
you hear?
Yes.
So I mean that your baseline regression just dummy.
No.
Regression is
No.
dummy.
Let me try to repeat what I said.
Yeah.
So we stick to the literature. So the first person to do this measure is a paper in the QG 2017, Rabareski and co-authors. And they look at business cycles. And they use this measure. And since the literature started using this measure, we use this measure. But because we're equally concerned about endogeneity as you are, because GDP is correlated with everything, we, instead of using GDP, just use dummies to indicate the exact timing of a discovery, which is zero otherwise. Okay? So the baseline is what I presented to you. To stick to the literature, but to address the concern you're having, we're also using just a dummy. And I would say this is by now very standard. So you're supposed to do both. Let's put it that way. You have a simple version, which is in line with the literature, and then you have 20 pages of robustness
But I
tests.
still wonder if you just look at, because you know, in my previous paper, referees asked us to do the same with Sasha Ligman. Just what will happen if you just do the same, but just get rid of GDP, not replacing by dummy, but just
Well, it will allow me.
keeping deposits.
I understand what you mean. So I think it will be something in between. The dummy is basically a more noisy measure of this, right?
Yeah. Okay.
So
But
the dummy is the simplest possible version to focus on the identification strategy. The identification strategy doesn't tell us anything about the size. The identification strategy tells us just something about the timing. So yeah.
okay, thank you.
Thanks.
Thank you, Gerhard. Bye.
Can I ask a simple question, please?
Yeah, please.
Well, thanks for the presentation, and I know that you tried to convince us that the timing is exogenous.
Yes.
My main question is, how would your results be affected if, by any chance, these discoveries are not completely exogenous?
So you're asking me in which direction the bias will go?
Yes. Do you have any thoughts on this?
Okay. Let me do the following. Let me actually do two things. Let me first, because this is something I didn't have time to do. Well, I also didn't want to because I think it would have been too much. So in the paper, we have a calibrated model. So essentially, a more sophisticated version of the very stripped down version which I presented to you, in which we allow borrowing, spending, and so on, forward-looking, credit-constrained individuals. And we calibrate this model to the experience of Canada, and then we shock the model with a discovery of 10% of GDP. So this is a simple structural calibrated model to the experience of Canada, and this is what Canada is giving us. And then we do the estimation I've shown you, and here we're comparing literally the model results to our baseline results. And you can see already that they're not significantly different from each other. So the confidence interval of all the estimates includes the estimates of the model. And I guess this convinces me. So this is exactly how we think about the channel, and the magnitudes are the same for the calibrated model and for the natural experiment. Now, you can see already here that there are still some biases. So here, for instance, you can see that in the model, you have, well, what? Actually, the manufacturing sector should collapse by more, according to the structural model, than it does in what we observe. And I actually do have a reasonable explanation for that. This is the typical protectionism of those countries. So if you have large discoveries, and Dutch disease is such an advertised idea, policymakers are aware of that, so they start protecting. So here, this is exactly what you see. So our discoveries are not completely exogenous because the discovery also impacts the policymaker who starts protecting against this mechanism, and it seems like partly successfully. The prices, for some reason, do not seem to be affected strongly. Yeah, but the collapse of the manufacturing sector, we end up having a upward bias.
Okay, well, thanks.
I have a question here.
Sorry?
I have a question here. I have actually two questions.
Yes, please. I have just one question to. How shall I deal? Shall I answer the questions in the chat, or shall I answer the? Let me answer the questions in which are coming straight ahead. I think that's this is
Seems for
more
me that
fruitful
it
for the
will-
discussion.
It seems for me that it will be the same question as in the chat.
Oh, okay.
No. It's it is one is that question, and other is other question is a bit different from that one.
Yes, I'm listening.
Well, you have taken 172 countries in your study. There are countries which are resource rich, and there are countries which are resource poor.
That's correct.
They are the ones who are importing the natural resources, for example, oil, gas. They are importing. So
Yes.
how will your model fit into for those resource poor countries?
Well, essentially, the only way those countries which never have a joint discovery feature in the identification strategy, the exchange rate relative to those countries will appreciate in the country which has a discovery. But since these countries which you're referring to, which are resource poor, do not have at any point in time in the sample a joint discovery, there is no within country variation. I'm not sure whether I'm answering your question. Maybe your question, so I was thinking from the empirical perspective, but maybe your question is related to how do we incorporate that into the theory? Is that maybe the question?
Yeah, somehow yes, and
Okay.
let me elaborate it more. For example, as is concerned, my country, Pakistan, it is not that much resource rich, and
Yes.
it is importing, having some explorations, some discoveries in the of oil. So
Yes.
how such countries will fit empirically in the model?
Well, such a country will, I mean, so the idea of Gordon and Neary is that you're operating with small open economies, which have a giant discovery. Since Pakistan is for the whole world a small open economy, but doesn't have resources, large resource discoveries, neither of the mechanisms we discussed, neither the resource movement nor the spending effect should be present. So I guess that would be my answer. Now, so the model has been written for countries which end up having resource discoveries and how those discoveries lead to reallocation of labor within the country. Since Pakistan didn't have any, it shouldn't impact Pakistan. I can turn it around if you wanted to link somehow to Pakistan, and there is a literature on this, which says that actually large financial inflows have very similar effects on an economy as giant discoveries. And it's easy to see because I didn't go into this because I thought there was too much information. Between the resource movement effect and the spending effect, by far the most important one is the spending effect. The resource movement effect is marginal. Even in a country like Russia, which is very resource rich, my guess is that total employment in the oil and gas sector in Russia doesn't exceed 300,000 people. So it's tiny relative to the rest of Russia. So even if there is reallocation to the energy sector, it won't impact the economy. But the spending effect is huge, and you can see the spending effect in Moscow. So the availability of caps and the prices of caps fluctuate with the price of oil. In fact, the whole exchange rate of Russia follows the price of oil. And the same will apply if you have large financial flow in Pakistan. So as soon as you have large inflows of financial flows, something like 8 or huge bonanzas of foreign direct investment, this may trigger very similar reallocation of labor within a country. I'm sorry, I cannot link Pakistan more. In principle, it shouldn't be linked because it is not resource rich.
And my second question, which I have posted in the chat box, is again like how will Dutch disease impact the importing countries and the sectors you have mentioned in your initial slides?
How will Dutch disease affect the importing countries?
Oil importing countries or resource importing countries.
okay, sorry, let me try again. Maybe I'm miscommunicating here something. So the basic idea of the Dutch disease is to think of reallocation of labor in a country which becomes resource rich. That's the basic idea. So you shouldn't have a Dutch disease, the classical Dutch disease, in a country which doesn't have any resources, because that's fundamentally related to the idea of resources. You can have similar effects, as I pointed out, like aid flows or other financial flows. But Dutch disease in a resource-rich, poor economy shouldn't be present. Let me try to push this a bit. There is one way which I can see how a resource boom and a Dutch disease in a large resource-rich economy may impact resource-poor countries. And this is but this is a long shot. Since there is a crowding out of the tradable sector in the resource-rich economy, if the economy is large enough such that the collapse of the manufacturing sector is actually significant for the overall global economy, countries which are resource poor could potentially benefit from this collapse by developing the manufacturing sector and exporting their tradable goods to the country which suffers from the Dutch disease. Okay?
Okay, I got your point. Thank you.
Thanks.
Any other questions?
May I? It's me
Sure.
again. Hi.
Hello.
Look, maybe I skip some of your explanation, but I still, I'm still thinking of exogeneity of your treatment, like discoveries, of course, with all, with all what you said. But generally, say, as far as I know, it says that the richer country or the bigger country, it might spend more resources on discoveries, on just on just geological, I don't know how to say it, exploration. So what, of course, it's to some extent quite random process, but in generally, how it depends on how much resources you can spend on it. How you deal with these sources of exogeneity? Given that you still have this, okay, your GDP in your model. It's clear.
Okay. Well, again, I cannot say much more than what I've said already. Nobody argues about the location being exogenous. Nobody does this.
No, but I'm not saying about, sorry for interrupting you, I'm not saying about exogeneity, in geological. Of course, there are some predictions, but how much resources can be spent on, geological, exploration?
Yeah, well, it's a location thing. It's not a timing thing, right? So Germany will spend more. That's what you're saying. Germany will spend more than Denmark.
No, I'm saying that given that there are some countries with expected deposit, you are not sure, but you can know if you know the geologic structure of your land, you can expect that you can find something. But depending on, say, political stability or size of economy or whatever, you can spend more or less on.
Yes, you're absolutely right. But that's not so the only situation in which your concern would be valid and invalidating the identification strategy is any of those time varying omitted variables which you have in mind needs to be systematically correlated with the timing of the discovery.
That's what I'm saying.
Okay.
There is a civil war. It might hurt.
Yes, but it needs to be systematically with the year of the discovery. That's what I'm saying. So your argument essentially suggests that on average, every time you have a discovery, you have the beginning of a civil war. Is that
it's
what you're
opposite.
saying? No, it's not what you're saying.
It's like you civil some tensions might hurt both price levels, so it might push levels of prices higher. We say non-tradable, and at the same time it might hurt the, I don't know, discover, or maybe it's opposite. You know, like there is a literature saying that if you expect a lot of, you know, discovery or a lot of discovery, it might push tensions. You understand? Civil
Okay.
tensions, like civil war. You know, all this conflict literature. Yes.
So let me try one more time.
Okay. No.
So if you, like, for me, I'm convinced. So if the company, so I talk to many oil companies and talk to many chief economists of BP, of Shell, of ExxonMobil.
Okay.
The oil companies do not know the timing of the discovery. So it's difficult for me to believe that there is systematic correlation between the timing of the discovery and country-specific variables, which are exactly co-varying with the timing of the discovery, because this would invalidate the identification strategy. I'm not saying that countries which have, I don't know, civil war are equally likely to have a discovery as countries which do not have civil war. What I'm saying is that the beginning of the civil war in one country is not correlated with the timing of the discovery. That's what I'm saying. And I think that's not crazy.
Okay, thanks.
Okay, any other questions? Then, Gerhard, if you wish, you could sum up.
Okay, actually, this is Hitendra from India.
Okay, we have one more.
Okay, I have one question.
Okay.
Dr. Gerhard, why natural resource rich countries are not that much developed and unstable?
Sorry, let me repeat it just to make sure that I understood the question. Are you asking why are resource-rich?
Why natural resource rich countries are not that much developed and stable? Yeah.
Well, I mean, as I tried to say, I think that's a myth. That's not true. That's incorrect. That's a wrong statement. So there is no evidence for that statement. So there are by now quite a few papers which actually show there is no, again, on average, there is no such thing as a resource curse. The most recent paper, which does a very simple, clean analysis, again, exploiting the timing of the very first discovery, and uses synthetic control methods to do this for like 20 countries, I think, is a paper by Brock Smith, 2016, Journal of Development Economics, and it's called Exercising the Resource Curse, exorcising, so just destroying. And there's really no evidence. So the paper by Sexton Warner, which pushed this idea of resource curse into the policymakers' hat and into many economists' hat, there is no evidence for that. On average, this statement is simply not correct.
And so talking about Malthus theory, nowadays in 21st century, it is not acceptable because of technological development.
I'm not linking Malthus theory in any way to the paper. My job, I thought today, was to talk about three things. A, to roughly draft how the literature developed. This is why I mentioned Malthus, because he's, if you want, considered to be the first resource economist. It's completely unrelated to what I discussed afterwards. It was an overview. And the other 2 points, which I thought are my goal today, is to talk about the basic idea of the Dutch disease and the main mechanism, spending effect and resource movement effect, and thinking about how identification can be done in a macroeconomic setting. But Malthus was just mentioned in the beginning to set the scene. So it's like mentioning Adam Smith in the beginning of a Micro 101 class. It's just it.
Mr. Gerhard, I congratulate you for your nice presentation. Thank you very much.
Thank you.